Here are the things you need to be able to do after this section. Let's take a look at the following. Cosine of theta equals 1 over 2. Okay, so two ways to think about this. When you take the cosine of what angle do you get out a ratio of 1 over 2? So if you look at your unit circle, you're looking where your x-coordinate is positive 1 over 2. So that's going to be in quadrants 1 and 4, since it's all students take calculus. And that would give you pi over 3 and 5 pi over 3, right? So cosine of pi over 3 gives you a positive 1/2, and cosine of 5 pi over 3 also gives you 1/2. But remember, right, theta could be pi over 3, could be 5 pi over 3, but we also have an infinite number of coterminal angles possible, right? I could add 2 pi in the positive direction or subtract 2 pi, right, this way. I have an infinite number of angles possible such that when I take the cosine, I get out the ratio of 1 over 2. Okay, let's come back to this equation for a moment. Let's say I want to get theta by itself. How can I solve for theta by itself? I can take the inverse cosine of both the left-hand side and the right-hand side. So you can't divide by cosine, you can never do that, right? You have to take the inverse cosine, and that would cancel these out. So you get theta is equal to inverse cosine of 1 over 2. And so here we have theta equals inverse cosine of 1 over 2. And remember, we decided that theta could be pi over 3, 5 pi over 3, and then there's an infinite number of possibilities because of all the coterminal angles. But recall that we're talking about inverse trig functions. And for functions, by definition, for every input, there needs to be exactly one output, right? Or at most one output. So right here, when I have an input of 1 over 2, my output of my angle measure just needs to be one answer. So not an infinite number of possibilities, I need to have only one answer coming out in order for the inverse to be a function. So for inverse trig functions, there are some implied restrictions. So let's think about this. If I have cosine theta is equal to some ratio, and if I have sine theta is equal to some ratio, right, so kotoa, and I have tangent, right, is equal to some ratio, right, tangent is when you stand at theta, take the opposite over adjacent, what is the ratio of the two sides? Okay, if for the cosine, if I take inverse cosine of both sides and I get theta equals inverse cosine of whatever the ratio is, there's an automatic implied restriction. So implied restriction. So if you see the superscript notation here, that means inverse cosine, there is a restriction that tells you that your angle theta, your output, your answer, must be between 0 and pi radians. We do this because it will limit your output to be just one possibility. So your inverse is a function. Note that inverse cosine could be written with a -1 superscript there, but sometimes it could also be written as arc cosine. Okay, so inverse cosine, arc cosine, same meaning, two different notations. Something else we want to consider for cosine theta here is that your ratio for cosine or inverse cosine must be between -1 and 1. Let's take a look at why this might be. Here's my y equals cosine of theta graph, just a little portion of it. Notice that my y values, my ratio, right, the cosine theta equals a ratio, is between -1 and 1. Therefore, my ratio must be between -1 and 1. And the implied restriction of between 0 and pi, that's just a restriction that was defined so that my little graph here will pass the horizontal line test, proving it to be an inverse function. Because if I didn't limit the graph between 0 and pi, right, if it kept going here, do you see how it would not pass the horizontal line test? Therefore, the inverse would no longer be a function. Okay, now let's take a look at sine theta equaling a number. Again, you have an input of an angle measure and you get out a ratio, a sine ratio, opposite over hypotenuse, or SIR, y over r ratio. Now if I want to get theta by itself, I would take the inverse sine of both sides, or the arc sine of both sides, and you would get theta is equal to inverse sine. anytime you see this notation right here, this inverse sine notation, or if you see arc sine, there again will be an automatic restriction. So there's an automatic restriction. And the automatic restriction for arc sine is such that your output, your angle measure, must be between negative pi over 2 and positive pi over 2. So here is my y equals sine theta graph. Notice that my output, my ratio, is also between negative 1 and 1. So your ratio needs to be between negative 1 and 1, just like the inverse cosine function. And if you look at the restriction, it's kind of weird. It's between negative pi over 2 and pi over 2. So the reason 0 to pi, right, would not work is because see how this little portion of the graph does not pass the horizontal line test? So the inverse would not be a function. So they had to choose a region where the graph would pass the horizontal line test, and that would be between negative pi over 2 and pi over 2, or at least that's one portion. And so by definition, that's the agreed upon region. Let's take a look at the tangent theta, right? If I take the inverse tangent of both sides so I can isolate that theta or that unknown variable, the tangent and inverse tangent cancel out, and I get theta is equal to inverse tangent, also known as arc tangent. Again, if you see in the original problem inverse notation or arc notation, there are automatic implied restrictions. And for tangent, your angle theta will be between negative pi over 2 and pi over 2 exclusive. And your ratio is going to be between negative infinity and positive infinity. In other words, it's all real numbers. Let's take a look at y equals tangent of theta, right? SOHCAHTOA or Sirkix or Tykes y over x. If I have some angle, I'm going to get out a ratio. Notice that here your ratio, right, is all real numbers. It's not limited between two values like negative 1 and 1 like it was for sine and cosine. It's all real numbers, and that's why your ratio can be between negative infinity and positive infinity. Looking at the angles that are possible, right, it's going to be between negative pi over 2 and pi over 2 because that's one full cycle before it repeats itself, and this passes the horizontal line test. Therefore, the inverse will also be a function. So negative pi over 2 to pi over 2 is the restriction for the angle for tangent. And notice it's exclusive of negative pi over 2 and pi over 2 because you have asymptotes there, right? You have asymptotes there. It's going to be undefined. Let's take a look at an example. It says find the exact value. What is inverse sine of 1 over 2? I notice that I have the inverse notation there, so I need to keep in mind the automatic restrictions that are part of the definition. One way to think about this is as follows. Sine of what angle would give me 1 over 2 such that your angle is between negative pi over 2 and pi over 2, right? Because those are your angle restrictions. So where is your sine coordinate equal to positive 1/2, right? Because of Sirkix or Tykes, where is y equals to positive 1 over 2? So that's going to be in the upper two quadrants, and that's at pi over 6 and at 5 pi over 6, where your y coordinate is positive 1 over 2. However, remember, we're only going to get one answer when you see that inverse notation in the original problem. Our answer must be between negative pi over 2 and pi over 2. Remember, negative pi over 2 is this way, and positive pi over 2 is this way. That means your answer must be between quadrant 1 and 4. So the only answer that fits between quadrant 1 and 4 is this quadrant 1 answer. So inverse sine of 1/2 is pi over 6. That is your final answer. Try this problem, see if you can do it. What is the arc sine of negative root 3 over 2? So here's another way you can think of it. It's asking you, given that the ratio is negative root 3 over 2, at what angle would you get a sine ratio of negative root 3 over 2 such that your angle is between negative pi over 2 and pi over 2? So you look at your unit circle and you look for where your y coordinate is equal to negative root 3 over 2. There's going to be two locations down here. And they will be at 4 pi over 3 and at 5 pi over 3. But remember, your angle needs to be between negative pi over 2 and pi over 2. So quadrant 3 is not part of your solution possibility. So you might think it's 5 pi over 3, But think about it, is 5 pi over 3, but in the restriction, is 5 pi over 3 a number between negative pi over 2 and pi over 2? No, it is not, because 5 pi over 3 is a number bigger than pi over 2. So the way we have to answer our quadrant 4 answers here, like anytime you have an answer for quadrant 4, you have to go in the negative angular rotation. So instead of saying 5 pi over 3, you have to say negative pi over 3. Where these are coterminal angles, I'm just going the negative direction instead of going the positive angular rotation. So your final answer, arc sine of negative root 3 over 2, is negative pi over 3, because sine of negative pi over 3 gives you negative root 3 over 2, and negative pi over 3 is an angle between negative pi over 2 and pi over 2. It's between quadrant 1 and 4, and if your angle is in quadrant 4, it needs to go in the negative direction. Go ahead and try this problem. What is the inverse sine of 2? Again, you can think of this as at what angle is your sine ratio equal to positive 2, such that the angle is between negative pi over 2 and positive pi over 2? Well, here the answer is actually undefined. And it's undefined because remember your ratio, your sine ratio? For your cosine and sine ratios, they need to be between negative 1 and 1. Right? Remember the graph? They're between negative 1 and 1. It's not going to go over it. So the answer is undefined. So watch out for these sneaky ones for inverse sine and inverse cosine, since the ratio needs to be between negative 1 and 1. If your number is beyond that, it's going to be undefined.